let's move to the next one now that we have a feel for this general strategy. So we need the inverse of the function. All right, y is 8x plus 1. So that's step 1, switching f of x with y. Now step 2, I want to switch x and y. So I have that x equals 8y plus 1. So this is the step where we actually invert the function. Now we need to resolve this for y. And whatever we get for y, that will be equal to our inverse function. So subtract 1, so x minus 1 equals 8y, and then divide everything by 8, so that y is x minus 1 divided by 8. And now that we've solved for y again, this is our inverse function. So, or at least we think it is. You never know for sure until you check it. So let's check our work here. So changing colors, let's do for f. Let's say we plug in the point 0, just because that's a nice, easy point to plug in. So we want to find f of 0. And so 8 times 0 is 0, so you just get 1. So this goes through the point 0, 1. And if this function is truly the inverse function, if we did do everything correctly, then this function will go through the point 1, 0. Essentially, these will just be switched when looking at the inverse. So we're going to plug in 1 and see if we get back 0. So we do f inverse of 1. So that'd be 1 minus 1 divided by 8. And 1 minus 1 is 0. 0 divided by 8 is 0. So it did work. We checked it, and we got the values we expected. So we can feel confident that this is the right answer. And let's do one more of these. So now we want to know what is the inverse of this h of x is 3/2 times x minus 11. So it's the same process. I'll set h of x, whatever your function is, equal to y. And we get 3/2 times x minus 11. And the next step is to invert this, switch the x and y values. So that x is 3/2 times y minus 11. And from here, we just need to resolve for y. So if you want to distribute first, that's fine. I'm going to try and get rid of this fraction out front. So I'm going to multiply everything by 2 just to start. So times 2 and times 2 over here. Since this is all one term, I don't need to multiply everything by 2 because everything's multiplied together already. So these 2's cancel. So you get 2x is 3 times y minus 11. Now I'll get rid of this 3 by division. So I can divide everything by 3. And again, it's just one term, so I just got to divide one of these factors by 3. So that becomes 1. So I get up here 2x over 3 is y minus 11. And then I'll just add 11 to the other side, so that y is 2x over 3 plus 11. And at this point, we'll just check our work. So we think that this is the answer, but we're not sure yet until we check it. So let me do that here, checking our work. So in the function f, we can plug in, let's just say 0. And actually, that might be a kind of a complicated number. So if we make this some kind of even number, then it can cancel out with the 2, and we won't have to deal with a fraction. So maybe I'll make this 13. So sometimes you do pick kind of more obscure values. You can definitely do 0. You would just have minus 33 over 2 that you have to plug into this one. So just a little bit more complicated, but you can still do it. And so f of 13, we'd have 3/2 times 13 minus 11, which is 2. And so, like I said, if this was even, then the 2's can cancel out in some way. In this way, they just completely cancel out, and you just get 3. So this point, or this function, goes through the point 13, 3. So now, if this was truly our inverse function, then when we plug in 3 into here, we should get back 13. So let me make room for that. So we're still checking, but now we're doing f inverse. And we know if this really is the inverse, I should set this equal to f inverse because we resolved it for y. And then when we do that, that's equal to the inverse. So if this is truly our inverse function, then it will go through this point, but reversed. So it should go through the point 3, 13, and that's what we have to check. So we're going to plug in to f inverse. We're going to plug in 3. And so you get 2 times 3 over 3, so those will cancel, plus 11. 3 over 3 is 1, so you get 2 plus 11, which is 13. And since you got back the the answer that we expected, we can feel confident that this is in fact the inverse function, and we can put this into our box here. And actually I just noticed that this really deals with h. So everywhere I wrote in f, you can just think about it as h. Doesn't really matter, those letters are kind of interchangeable, but I did want to point out I did make a mistake writing out all these f's when I should have written out h.